Kia ora, hello to everybody who's taking Year 12 Physics at Girls High. Here's an interesting and tough question that was found on the Level 2 Physics workbook, the green one that everybody bought. It's on page 58, question 2. We've got a glass block with a beam of light coming in at 40 degrees, and that beam of light is a mixture of red and violet light. It intersects, and we're going to put in a normal there. The violet light bends a wee bit, and the red light bends a little bit less. The incoming angle is 40 degrees. The refractive index in air is 1, and the refractive index of red light in the glass is 1.513, and that's found on the previous page, I think, than 58. And the refractive index of violet light is a wee bit higher, which causes it to bend a bit more in. I'm going to continue the normal all the way across because that'll be useful. Right in the angles we want to find that violet angle from the normal and the red angle. So I'm going to make this a bit smaller and rewrite the information. So the block is a bit smaller. There's the angle we want, theta V, theta R for the violet. And the first thing I do is I write down Snell's law. N sine theta is equal to the other n times the other sine theta. And we've got the refractive index in air times the sine of theta in air is equal to the refractive index of the red light times the sine of its angle. And then we can write those numbers in. That's 1, excuse me, times the sine of this angle here is equal to this refractive index times the sine of this angle. Well, I'm going to do a complicated step called swapping sides. And so therefore this stuff comes over here, this stuff comes over here, and I put the 1 in as a dotted line because we want to get rid of that. Then I want to divide both sides by this number here because that way we'll get rid of it like this. And then we finish up with this sort of thing here. So this thing here is equal to this stuff. Then I can find the inverse sign, or on a calculator the shift sign, the inverse sign on both sides, because the inverse sign of the sine is equal to just the angle, and these two things disappear like that. And the angle is equal to this stuff, so the inverse sign of this thing here is 25.141, and we can write that up here like this. Then we do something similar for the violet angle. I've deliberately written the Snell's law around the other way, so refractive index in air times the sine of the air angle, refractive index of violet times the sine of the violet angle. That just saves me having to swap later on. 1.532 times the sine of the angle we want is equal to 1 times the sine of 40. Divide both sides by 1.532. That cancels. The 1 disappears, and we finish up with the sine of the angle is equal to that. We find the shift sign as before, and the inverse sign of the sine of an angle is just the angle, and we can calculate this, and we get 24.808, and we can write that up the top and then get rid of all of the calculations down the bottom. Then I'm taking out of here 2 right-angled triangles. There's a violet one, which I've represented as blue, and the red one slightly taller on one end that I've represented there. Let's put some information on it. There's the blue angle, 24.808. There's the red angle, 25.141. There's the thickness that we really want to find out. There's the difference in the location of the beams on the other side, 1 centimeter, and that's a height from the normal. It won't come into anything. I can call it what I like, but it's just we need that as a symbol. Well, we can then get rid of the stuff at the top and then move this information up to the top to make room. Then I can write down 2 equations. For the red triangle, and I've done this in orange, the tangent of the red angle is equal to the opposite. For the red angle it's h plus 1 divided by the adjacent, which is t. And for the blue angle, the tangent of its angle is equal to its height, just h, divided by t. Well, the next step is I'm going to do a complicated step called swapping sides there, and the same on the other side. Nothing very complicated. I just want to have h on the left. Then I can multiply both sides, on the left hand side, if I multiply both sides by t, like this, and then what I can do, that t will cancel, but I'm not going to do that yet, and I can multiply both sides on the right by t. And that gets rid of the denominator. So we can cross those out and write h plus 1 is equal to that from there down to there, and ditto here, h is equal to that. Then, this one's h plus 1 and this one's h. So for a reason which I'll show you in a moment, I'm going to keep that one, then add 1 to both sides on the right hand side. Now that's kind of cool because this thing here is the same as this. Well, if this is the same as this, then, and these things are equal, then this thing here is equal to this thing here. We can get rid of h. So this thing is equal to this thing here, all that. Then I can subtract this term here from both sides. If I do that, that cancels because this minus itself is 0. And on the left hand side I can write t times the tan of the bigger angle minus t times the tan of the smaller angle is equal to 1. I'm now going to transfer to the top of the next slide like that and try and solve this interesting little equation, because we've got one equation with one thing we don't know, and the thing we don't know is the thing that we are looking for, so we're homing in. I'm going to take out t as a common factor. T is in both of those. Take out t as a common factor, and then that's kind of cool because this big thing in this bracket here is a single number, and I can divide both sides by that same single number. I'm a bit short of room here, sorry. Well, on the left hand side, divide those things, cancels, finish up with 1, and t is equal to 1 divided by that. Well, now this thing here is a number, and I can divide 1 by it. T is equal to 1 divided by, well, this thing minus this thing gives us that small number. And if I find the reciprocal, 1 divided by that, I get 141.38 centimeters, or 141 centimeters rounded to 3 significant figures, or 1.41 meters. And the nice thing is, that is what we wanted. I hope this has been useful.